Alright, so today we're going to look at VEWAC of the systems, and this is going to go back to something similar to that we did earlier with VEWAC. So what I actually want to do before we do the front of this is flip over to the back, and I want to think about some of the coin questions that we used to do. So think about if I told you there were 25 coins and you had some quarters and nickels, and there was a total of $4.45. Okay. Back in October, when we learned how to do this, we would have said let x be the number of quarters, and we would have said let 25 minus x be the number of nickels. Well, and then we would set up an equation and we would solve that. We can actually answer this same question now, but we don't have to use just the letter x. Now you have the capability of using y as well. So now, if I want to look at this type of question, I could say, well, I have some quarters and I have some nickels. So I could set them up as two different variables now, because now you know how to set up an equation and solve with two variables. So using this idea, knowing that there's 25 coins, I would start by saying x plus y equals 25. Some nickels and some quarters, altogether 25 coins. And then I would create a second equation that involved all the money. And that would be, well, I know quarters are 25 cents. I know nickels are 5 cents. And I know I had a total of $4.45. So there is how you can use a system of equations to solve this problem, where you've got two variables and you've got two equations. This is the kind of thing that we're going to do over the next couple of days. So as a first example to actually do, that really is the first example, but I want to go through this. So I think you saw one of these on one of the sheets that you had a couple of days ago. Joe and Emily are at a snack shop and decide to buy pretzels and nachos. So we're going to buy two different things, some pretzels and some nachos. They decide to buy a total of 9 snacks. Each order of nachos costs $4 and each pretzel costs $2. Together, Joe and Emily spend $22. And here's the actual question. How many of each type of snack did they buy? So we go back to our VEWAC strategy. The first strategy is to define the variables. So we're going to let x be, and I'm just going to do this in order. I'm going to say let x be the number of pretzels. Notice how I am being specific by saying it's the number of. Okay, and now the other one is nachos. I'm going to use a different variable, so I'm going to let y be the number of nachos. If you wanted to, you could use p and n. I'll show you in a couple of minutes why I'm using x and y. Okay, so there's our v. Now we have our e, and notice it says write two equations, because one of our equations is completely about the 9 snacks sold. Knowing that x is a number and y is a number, and of course 9 is a number, our first equation is going to be x plus y equals 9. That equation right there is totally about the number of items that were purchased. Now I want to write an equation that relates x and y to the money they spend. They spent $22. We know that each pretzel costs $2. Pretzels was x, so I can set this up as 2x. Nachos cost $4, so this would be 4y, a total of $22. There is our system of equations that has two variables, so there are two equations. Now our work is spent solving this. If you notice the way this looks, when we do these VEWAC problems, this is my preference, but I noticed that this is lined up exactly like I've seen the past couple of days. So a lot of times I'm going to do these using the elimination method. So if I do the elimination method, I'm going to take this and multiply the top equation by -2. Please think about why that is. What am I attempting to do by multiplying that by -2? So this would give me -2x minus 2y equals -18. My bottom equation was 2x plus 4y equals 22. I see a pair of opposites, so I'm going to add. And when I add those, the x's go bye-bye. These give me 2y equals negative 18 and 22 is 4. Divide by 2 and get that y equals 2. And now I find this particular one very simple. If x plus y is 9 and y is 2, then I automatically know that x is 7. And there's my answer. I just have to remember that in a VEWAC problem, my answer is always a statement. So I'm actually going to come all the way down to the A part of this where it says state the answer. Knowing that x was 7 and y was 2, as we found up here, I can say that we have 2 nachos and 7 pretzels. Okay, I already know I have that answer. Now, to verify this, you're not always going to have to graph these, but I do want to graph this one just to show you how this actually works. So let's set up this graph. If I'm going to graph these two equations from up here, then I have to realize that neither one of these are in slope-intercept form. So I'm going to start with x plus y equals 9, and I'm going to get y alone. So I subtract x on each side, and I get y equals 9 minus x. Do the same thing to the other equation. The other equation was 2x plus 4y equals 22. To isolate y, I subtract 2x, get 4y equals 22 minus 2x. Divide everything by 4. Notice that it doesn't work out all that nicely, but it's also not terrible. I get y equals, what is this, 5.5 minus 0.5x. I would normally use fractions, but the reason that I'm going to do this one, notice that the graph does not have any scales, and we got to figure out the scales. So what I'm actually going to do is go to my calculator. And if I go to my calculator and I type in the two equations, so there's 9 minus x. So I go to my table. Now I'm going to write down a few of the numbers in this table. So I have my x and my y. And I have 0, 9, 1, 8, 2, 7, 3, 6, 4, 5, and so on, and so on, and so on. I more want to do this for the other equation because of the decimals, and we really don't like the decimals, especially when we're trying to graph. So if I go in here and I do 5.5 minus 0.5x, and I want to see the table on that, this isn't bad. Notice that every couple of cells in here I have whole numbers. So I'm going to copy down my XY table, and as you've seen me do before, I'm really only interested in the whole numbers. So I'm going to do 1, 5, 3, 4, 5, 3, skip 7, 2, and 9, 1. But the other reason I'm going to do that is because now this gives me an idea of how I want to label my axes. Notice that I don't see any negative numbers, which means I'm going to use one quadrant. So I'm going to put 0 right there. But my x's, I'm going to skip and go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I'm actually going to do exactly the same thing for the y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's not forget that because this is a one quadrant graph, I do have to label everything. Way back up here, we said that x stood for pretzels, so I'm going to label this as the number of pretzels. Label this as the number of nachos. Okay, now let's do our graphs. Let's do this one first. It's 0, 9, and 1, 8, and 2, 7, 3, 6, 4, 5, Once you've got a few points, that's enough to draw your line. Okay. Now graph the other one. Be very careful with what you're doing here. So I start with 1, 5, and then 3, 4, 5, 3, 7, 2. Well, that tells me something right there. And then 9, 1. Okay. Notice I didn't use the y-intercept, but that's because I really didn't need to. So there's my line. Okay. Notice those two lines intersect right there. What are the coordinates of that point? Notice that they're the point 7, 2. Okay. So that's what it looks like on the graph where those things intersect, as we should have already known. All right, and as always, the last part of any VEWAC question is to check. We think the answer is 7, 2, where x is 7 and y is 2. My first equation is x plus y equals 9. 7 plus 2 is in fact 9, so it checks. My second equation was 2x plus 4y equals 22. So that's 2 times 7 plus 4 times 2. And we get 14 plus 8, which is in fact 22. So this is our VEWAC systems. We're going to practice a lot more of this in class. If you have any questions, please be ready to ask. Have a nice day.